Hello, everyone. Thank you so much for coming today. Welcome to Cyclone RoboSub. We're very excited to speak with you guys today. My name is Jason Peak. I am one of the co-presidents of Cyclone RoboSub. I'm joined here today by my wonderful leadership team. Before I move on, we're going to each share a little fun fact about ourselves. I'm from Los Alamos, New Mexico. Sorry?
They weren't prepared for their.
Oh, you weren't prepared? We gotta think quickly. I'm from Los Alamos, New Mexico. For those of you who've seen Oppenheimer, that's where the atomic bomb was built. So that's where I'm from. That's where I'm from.
Hi there, I'm Peter Webster. I'm also third year mechanical engineering like Jason. And I'm the other co-president of the club. Fun facts about me, I like surfing, like the ocean. Yeah, I like everything about this club.
Hi, my name is Nidhi. I'm a third year electrical engineering major and I'll be this year's co-electrical lead. Fun facts about me, I'm from San Jose. I play the violin. Yeah, I don't know.
Hi, my name is Anjani. I'm the other electrical lead. Fun fact about me, I'm top 5,001 very specific Tetris game mode.
Hey everyone, I'm Sunny and I am the research lead of RoboSub and I am a chemical engineer and I'm also a junior. A fun fact about me is that I love fish tanks. You can probably see in that profile picture, I have like 3 fish tanks behind me. Apparently we used to have 10 fish tanks, but once my parents had me, they had to remove 6 fish tanks. So apparently it takes the same effort for 6 fish tanks to raise me, I guess.
Hi, my name is Sam Asbell. I'm a 4th year computer science engineering major. And a fun fact about me is I like metalworking and backpacking. Yeah, those are my 2 big hobbies. That's all I really do outside of school.
You can look at the project. I like just project. Okay.
Here we'll project. All right. So just to give you guys a brief overview of what we're going to do today, we're going to briefly introduce sort of what it is, what we do, why we do it, how we do it. Then we're going to talk about how we're structured, and then how you can get involved in that. Then we'll have some time for questions. Feel free if you have a question in the middle of the presentation, just hold on that to the end, and hopefully we can get around to everyone. We have room for the full hour, so hopefully it doesn't go that long, but we're here and we want to speak with you guys and see what you guys are interested in.
Okay.
So before we hop into Cyclone RoboSub, I want to take a brief moment to talk about clubs in general. How many of you guys are freshmen? Raise your hand if you're a freshman. Oh, a lot of people. Not you. How many of you guys are transfer students? Okay, we've got some transfer students. So for those uninitiated, when you come to Davis, you're gonna go to your classes, you're gonna go to your engineering classroom, your professor's gonna teach you some cool equations, you're gonna do some cool math problems. That's gonna get you about 50% of the way there in with respect to being ready to operate and work as a full engineer. Your professors are going to give you the tools that you need to solve problems, but if you want actual experience applying that tool set to real world applications, you do that in an engineering design team like this. There's a lot of really great teams here at Davis. I highly recommend that you guys also check them out. Ultimately, we're each trying to provide a very similar thing. And basically that's giving you experiences and opportunities to challenge yourself and to actually have tangible things that you can talk about to other people. Because what's gonna happen, you're gonna come to one of these team meetings, you're gonna join one of these teams, you're gonna get a bunch of experiences, you're gonna build systems and mechanisms and program different sorts of automations, and all that is gonna help you be a better engineer. And you're gonna do that, you're gonna put that on your resume. People around you are gonna be able to better understand the work that you have done and the things that you are capable of as an engineer. And while you're doing all that, you're also building a community. I know engineering is head down, we want to study, we want to do all the work. it's very important also that you're doing it with people that have shared interests and want to also do the cool work with you. And you're going to find that most successfully at an engineering design team. And ultimately, what that community is going to turn into is when you graduate and you go into the real world, and you're out there working with different industries and companies and startups, is that you're going to be able to have a network of different people across the workforce that then you can reconnect with and be like, hey, I worked with you in college. You were really cool. You knew a lot about control systems. And you know, you're going to be able to pass up jobs, information, conferences. It's a whole interconnected system. So, like, if there's one thing that I want you to take away from this presentation, is that part of your education as an engineer at UC Davis is joining an engineering design team. You have the schoolwork, and then you have the club work. The rest of this presentation, we're going to talk about what we do and how we do it. But hopefully, and using that information, I hope that you can then choose and devote your time here at UC Davis to at least one or more of those teams. Cool. Excellent. Oh, it's on this one. Just press the space bar, that works.
Yeah. So we just wanted to go in really quickly to how all this got started. So we're a second year team. So we officially started and had our first full year last year. But the reason we started this club in general is because Jason and I both arrived here at UC Davis, and we're really kind of disappointed with the opportunities for robotics type experience. We had both come from kind of competitive robotics backgrounds in high school. We wanted more of that. We got here and there wasn't anything. So we kind of started this club as a way to kind of address that niche here, and then also create a community surrounding robotics and like mechanical design around robotics. And I do really want to emphasize that community aspect. Like, we are here as a competitive team, but the reason we started RoboSub is to meet other engineering students who are interested in robotics. That's kind of the whole driving force behind our team. And I think it's like really important that you understand that now, as in like above everything else, we will prioritize our community and kind of like building up students. Like, we are here for you to teach you. We're not here for like to be hyper competitive in a competition. We want that, but ultimately we're here to teach you. Did I hit everything?
Yes,
Yes, thank you. And that kind of leads into our mission of, yeah, providing hands-on opportunities for students like you guys interested in robotics, also meeting you at any level. So bringing in freshmen who have come from backgrounds of engineering or robotics, or people that are completely new to this sort of field, or people outside of engineering majors, but bringing everyone in and giving them a place where they can kind of learn with where they're at. And then also our values as a team, we really value accessibility. We try to make this team really easy to join with no registration fees, welcome you in, make the registration process really easy. Also in shared mentorship, we want to pair the people that really know what they're doing with the groups of students that are learning. And we hope that through that model, we can kind of spread the knowledge, spread the wealth, and then lift everyone up. And then lastly, transparency. We try to be really clear with how we're running this team, because we feel that that's fair to you. And we want you to be transparent with us about what you want from this team, because ultimately we're still pretty new and we're still developing things as we go. And then communication, that's kind of falls in with transparency, but we want to hear from you, and we want to know if you want to hear from us, or we will communicate with you. Yeah.
We're all busy college students, so ultimately we want to give you as much information about what we're doing so you can make the decision, the best informed decision on how you want to spend your time here at UC Davis.
Okay, so going into what this club is actually about, because that's what you're here for, right? So we are an engineering competition team, like Jason mentioned, like a lot of other teams here on campus. And like I said before, the competition is the motivator, not the goal. So we're a second year team and the go-to place for robotics, and that's what we're trying to become. And then a safe place to socialize. Our plan is we're trying to create a community, so we do social events on top of competition and work sections. And then we're also research oriented. We're trying to use the technologies that we develop in research and environmental applications, and also publish some of the work that we do here as a club. And that feeds into what the RoboSub competition is, which is the competition we compete in. So it's an international competition. It's held in Irvine right now. Sometimes it's held in San Diego. But about 40 teams come in, both at college and high school levels. It's international, so you have a handful of maybe like 10 international teams coming in. Most of them are US-based teams coming from like top robotics universities like Carnegie Mellon, and then you have like community college teams. But there's a really wide kind of mix of who's coming into this. And the competition kind of consists of 30-minute challenges where you have a robot that is submerged, and then it has that 30-minute run to complete as many tasks autonomously as possible. And there are judges in the water watching your robot and marking how it does. And then I'd also add that this competition is not just based on how a robot performs, but it's really based on also like our ability to present and showcase our work. And then also like our website and our media. It all feeds into how we do in the rankings of that competition. It's a very holistic competition. And like I said before, it occurs every summer.
So here's a little look at a robot. If you've been to any of the engineering design events, the team fair, club fair, you got the chance to see that up close. You will get the chance to work with that hands-on. It's still got a lot of work. It looks complete. It's not. It's there's a lot of opportunities for improvement. So that's what you can look forward to.
And we'll go back to that later, maybe when questions come around to reference it. We included this slide just to kind of give you an idea of the breadth of types of robots that are out there. You saw our design. These are like 4 other designs that other teams have submitted. Most of this is CAD. This is all CAD, but the teams have built these, and it just kind of gives you an idea for the different types of ways that teams approach this like same challenge of designing an autonomous vehicle.
All right, so we're going to hop into the team structure. So we here at RoboSub are divided into 2 different kinds of groups: sub-teams and divisions. Sub-teams are going to be where you're going to be spending basically all your time. They are defined by the part of the robot that you are working on. So you can see navigation, propulsion, hull, manipulation, research. Everything excluding research is a part of the robot that needs to work in order to compete at the competition. Navigation, you can assume that's can the robot sense its environment? Can it navigate through the environment? Propulsion is the process through which we actually are moving through the environment. The whole is the physical system of the robot, and manipulation is the torpedoes, all the extra stuff on top of that. And all of our sub teams are going to talk a little bit about their sub team and what you should expect working with them. Sorry, I'm not quite done yet. Within divisions are less so a group of people to be working with, but are more so the structures and the people who have similar skill sets as you. So if you're a mechanical engineer, you will definitely be on the mechanical division, but that's not the only thing you need to be on a division. If you have an interest in learning software, say you're coming here, you're like, I really want to learn about image processing, but I'm a biomedical engineer, I have no experience in the field, that's totally okay. You can also be in the software division. It's very cross-disciplinary in that way. And we leave it open to you to choose what you want to spend your time in. Divisions become a lot more important when we talk about leadership and the support structure that sort of underlies how we encourage learning with our team. And we'll jump more into that when we talk about leadership positions. But just to give you an overview, sub-teams are where you do the work. Divisions outline the kind of work that you do.
All right, so basically the navigation team, as was mentioned before, the robot is completely autonomous. So we'll obviously do some preliminary testing with like a tether of some kind, perhaps even an IR remote control. But once it's actually in the competition, it's going to be completely autonomous and it has to effectively figure itself out around the course. So this is going to involve a machine learning adjacent computer vision model, which we have effectively chosen, but we have not implemented it yet because there have been a lot of uncertainties as to what the robot, the topology of the robot and everything. So basically what we're going to do throughout the year is we're going to work with, well, vision is our team, but propulsion and manipulation in order to get kind of a picture of how we can integrate the computer vision algorithms and let it do its work inside of this sort of closed control circuit. So yeah, it's obviously very software based. So you'll enjoy working with me if you like programming, okay? At not only a high level, but also a low level, because we actually need to push the stuff onto the embedded system. In terms of specific areas, obviously you don't need to be intently interested in these areas, but it is a plus, okay? If you like computer vision, embedded systems, or control theory. So if you have absolutely no intense software experience, but you just are interested in, say, for example, control, or just say computer vision, right? You can learn that in this club, okay? But I highly suggest taking the courses as well, Davis, if you have the ability to do so. In terms of our actual stack, we will be using OpenCV, specifically in Python, and we will be using ROS. It's probably also going to be in Python. It's basically the library which allows us to create all the different closed control circuits that you'll see that interact with manipulation and vision and all that. And then the actual computer we will be using, we'll actually be using multiple computers, but one of the ones, as an example, is the Raspberry Pi 5. How many of you have worked with Raspberry Pis before? Yeah, it's a pretty common chip. But yeah, that's going to be, that's my team.
So for propulsion, basically where we are at right now, we currently have a system with 4 vertical thrusters and 4 lateral thrusters to move the robot up and down, left and right. And we also have custom mounting brackets that we've designed and are machining currently. This year, the main plan for propulsion is to have a heavy focus on control systems. So if you want to work on controls, propulsion and navigation are a good place to do that. We'll be working a lot with them for the software part, and a lot of the controls for propulsion. We'll be working on thrust allocation to be able to move to desired locations. And we're also going to be working on dynamic modeling for the robot in simulations. For future projects that we have planned, we also want to design our own custom thrusters. So if you want to do that as a project, you can also come to propulsion.
Before we continue, also, I want to emphasize that this is just as programming heavy as navigation. These are equal parts programming and electronics. So definitely, if you're interested in programming the robot, these should be equal in your mind, more or less.
So I'm going to be covering whole for now. I'm not the whole lead, but I'm covering it for the sake of this presentation. So the whole basically encompasses all the vehicle structures. Anything physical that you see on the robot besides the electrical systems, that's kind of us. So we kind of like designed the base plate for the robot, all the 3D printed brackets and handles, and then also the vehicle structures. So that includes machining everything, printing everything. And then Hull also has a big emphasis on waterproofing because this is an underwater competition. So that's looking into how to design with O-rings, how to like ensure like successful seals, and then also doing pressure tests and doing tests like within the pool to basically validate our systems and ensure that, you know, we don't stick it in the water, the thing floods, and our electrical systems go out. There we go.
So manipulation focuses on the competition challenge tasks. Some of them include designing torpedoes, like the housing chamber, and launching mechanisms, a dropping mechanism to drop any sort of object into like a bin, or a claw and arm to manipulate and move around different objects. So as part of manipulation, we started with research to understand what other teams have done and what they have accomplished to see like what we want to design. And one of our goals is modularity, to design these subsystems to be independent and function so that it allows us for like easy testing and implementation.
And then I'm also covering this one for the sake of the presentation. Our PR lead is not here today. But public relations essentially covers everything that allows the team to run. So that's everything from business. So that's our team sponsorships. This is an expensive project. Outreach. So communicating with other organizations here on campus and outwards, like communicating with other RoboSub teams. We also do a monthly newsletter for our sponsors, and then also managing our social media and kind of reaching everybody for recruitment, and also just to promote the cool work that we're doing. Lastly, kind of also includes like club bonding. So when we do social events, news events, and then our finances, we have to track all of our purchases and work with our faculty advisor to ensure that we're doing good bookkeeping and we're being responsible. And we also work to plan kind of the trip to the competition. This will be our first kind of like full official trip to the RoboSub competition in Irvine. And there's going to be like a lot of planning around that to make sure everyone has a good time and like accommodations are provided, and just like make sure it's a cool trip. Yeah.
All right, so the last sub team that we have is research. And this quarter, we will be implementing a water sensor onto our robot. Just to clarify, this is not part of the competition. We are doing this solely for the purpose of collaborating with the Tahoe Environmental Research Center. So we will collect the water information and send it to the research center, and they'll do whatever they need to do with that information. And of course, we will be working with our professor on publishing control works. And we will also mess around with a bit of FEA, also known as finite element analysis, where we mess around with flow dynamics and also figure out how materials work under certain environments and conditions. So yeah.
All right. Yeah, you want to do
Yeah. So just looking forward into this year as like a really like broad set of goals and overview. We kind of break this down by quarter. And our end goal is the competition this summer. But this fall, we're planning on doing a series of trainings for the first month, kind of getting people up to speed to learn a little bit about sort of just like basic things like electrical systems and motor control and design. So that's our Battle Boats project. We're also planning on redesigning our electrical system to implement more safeguards, implementing tethered control so we can basically drive the robot via remote, and then also fundraising for the coming season. Winter, this year is kind of our big controls year. We have a physical robot, electrical system is there and working, but this year is kind of like our time to really focus in on the autonomous capabilities of a robot. So that's going to be implementing the control software, implementing sort of our inertial motion unit. So that's the IMU, and then doing camera testing. And then lastly, designing our manipulation systems for the tasks and prototyping those. And then spring will be full autonomous testing in the rec pool. Pool testing, documenting our work for the competition, and then video submissions also for the competition. And then summer, couple more tests, kind of wrapping everything up and fine-tuning things, and then going off to Irvine and seeing how we hold up against the 40 other teams.
All righty. Okay. So if any of what you've heard today is like, I want to do this, like this seems cool, even if it's just for our Balboats training. First thing you're gonna do, you're gonna register with the team. What's gonna happen is we're gonna go home. We're gonna give you a moment on Discord. I'm gonna send out an announcement with the registration link. You're gonna fill that out. That has a lot of really important information, and that's how we get you online with all our databases and everything that we use to make the club run. The idea with this is that this is going to be only open for about 2 weeks. So you have a 2-week period to come to our club, check us out. At that point, if you're interested in sticking around, definitely register. If you're trying to register after the deadline, that's going to be a lot more difficult. It's very difficult to accommodate people constantly joining the team, and especially with the battle boats, it's a very much like we're going to hit the ground running. It's better if you start with us than if you join late. Meetings coming this quarter, and this will change quarter to quarter based off of availability, is the main general team meeting will be happening on Saturdays from 1 to 3. This weekend, it's happening here at the TLC in the room directly above us. In the future, that will be happening at the ESDC. We're trying to get some permissions figured out right now. And that we will have access to be able to work with the robot.
Can I interject? Yeah, and if you're new, the ESDC is the Engineering Student Design Center, so that's the building behind us, and we usually kind of like work on the ground in the classrooms there. And then also for those 2 weekday meetings, those times are kind of to be decided as we like talk with the ESDC staff and also with our own leadership team. But you can expect probably 2 2-hour meetings during the week. In the evenings hosted by different leadership members as an opportunity for you to come in and work on some of their projects for the battle boats training and then later for the team. and that'll be announced on the Discord.
The idea is to have enough options for you to come in that you don't need to come in every single meeting, but if you can make it to one or even two, then you'll be in a very nice spot. Also, keep out in the future, we'll be having a social, and after the battle boats training, we'll jump back into our sub-team divisions, and we'll be focusing on the robot.
So yeah, for clarification, for this first month, we will be entirely focusing on trainings. After that first month, we're back to grinding on the robot.
So if you're like, oh my God, I love this seems so cool, you should think about joining leadership. We have a lot of positions open. Like, because we're going to be focused primarily on software, if you have any amount of software experience and you have interest in leading, you should definitely apply. There's a software division lead, which is a software position, but also propulsion and navigation are also essentially software roles, very software heavy roles. I want to emphasize that you do not need to have those experiences. We're very holistic in the way that we look at our applications, but there is a cross section between your command in a subject and your ability to properly lead in that subject. So we'll be taking that into account, and the application is very thorough. The application will be open for also 2 weeks. There is just like a little bit of general information, and then there are 3 essay style questions. You can pull out your college app essays if you really feel like it. That's not really what we want. We're more so checking to see that you're someone who's motivated, that you have the ability to execute on a vision, and that you understand what it takes to work with other people, right? I want to also emphasize that even if leadership is not your thing, there's a lot of just technical work that's happening that if you're at all interested in anything, that you should really consider at least joining the team. And if you stick around and you end up really liking leadership, is there's a lot of people, like we have Sam, you're the only one graduating, are you?
Yeah.
Okay. There's one more leadership position opening next year at least.
Yeah, and the reason we have so many positions open is because we're still a new team and we're still expanding a lot. And also trying to figure out what works and what doesn't work as well. And we found last year that we really valued the idea of having division leads. So people that have a bit more experience in each of the subjects, or each of the kind of main engineering aspects of the robot, who can kind of oversee the entire technical scope. So if you feel that you have a strong kind of background in any of those sort of areas, or even just any sort of experience, consider applying. And then for those sub-team leads, those we're really just looking for initiative and kind of the willingness to step up and jump in on a project and work with people. So if you're interested more in something like that, sub-teams are a good spot to apply. Thank you.
All right, well, at this point, we've gone through the presentation. We will open up the floor for any and all your questions, and after that, we will be sticking around a little bit if you want to just talk to us individually. In that case, thank you so much all for coming.
And I want to add one more thing. We'll do formal questions, and then if you are interested in leadership, I recommend once we've done formal questions, come up and talk to some of our leadership team afterwards so we can meet you. And then kind of look out for your application and get a feel.
It's called networking.
Okay, yeah. Okay, back around. Any questions?
I saw. Yeah.
Will this robot go into Metal?
So we are currently here. Can better talk to this.
Yes. So the idea with this is that once our vehicle is fully operational with a tether, we have opportunities and connections with people at the Tahoe Environmental Research Center under UC Davis. And the plan would be, we talk with them about what their needs are for underwater imagery. And then we'll go up with some of their researchers, possibly go deploy the robot in either Tahoe itself or one of the surrounding lakes, capture some imagery for them and pass that along to them for areas that are usually pretty inaccessible. That's kind of our goal right now for, yes.
So another question.
Yeah. Let's say that
you were able to go to the like the battle bolts training like this Saturday, are you like is it still fine to still apply? 'Cause-
Yeah, so registration is open for 2 weeks. That's your grace period. Within that time, you should plan on coming to at least one of those meetings. Again, we understand that you're busy and that what's going to probably happen for a lot of people is that the quarters, like we're not still in the start of the quarter. As the quarter goes on and as midterms roll around, you're going to get busy. It's going to be harder to cut, and that's expected. That always happens. That's a universal thing. So we expect that, but we do want to know if you are interested in sticking around within a 2 week period. So if you can't come this Saturday, that's okay.
Yeah, I think you should expect like 2 to 4 like hours a week for the first month if you really want to like get something out of the training and like actually learn. If you're not coming in like consistently, like it's kind of up to you. It's like you get what you put in, right? So the more time you spend here, like learning skills, the more skills you're gonna get. If you come to like 2 meetings over the course of a month, you might like learn a bit, but not really be able to like dive deep on this project. And we'll explain more on Saturday, but they're kind of like competitive team-based projects where we're trying to encourage you to work with a team and collaborate together, and like you're incentivized to do well. Yeah.
How's the robot powered?
We have two 12 volt
14.8.
14.8 volt batteries. They are lithium ion, and if they come in contact with water, they will explode.
So they're inside of the robot?
They're inside the enclosure. Yeah. Do you want to go to the slide?
This is why I kept the slide around. Yeah. Yeah.
So like, are you not allowed to have anything connected to it?
Well, you can like there's like a safety rope during the competition. No,
There's no safety.
there's no safety rope. There's no safety rope.
So it's an autonomous competition. So like underwater communications, like generally like really difficult. So that's why it is an autonomous competition, because the competition's trying to encourage students to learn more about like autonomous technology, because it's the only thing used in the marine robotics industry. But this club isn't focused on the marine robotics industry. We just use this as our project. But yeah,
Also, question in the chat, how long will the Saturday battle boat session go for?
3 hours.
No, I think
No,
we're
no, I
covering
think-
Saturdays.
So we're
Both, I guess.
the
Yeah.
expect a month to 4 weeks
Yeah.
is the expected timeline. Like if you want to work with the robot, you need to start with the battle boats, because that's where you're going to learn the base skills you need in order to be able to work with the bigger robot.
Are those technically training or are they?
They are the same thing. Yes, it's more fun to call it battle boats because you're going to be trained while you're making cool boats.
Yes.
What exactly are those things you'll be teaching us for that first like?
Yeah.
Like what?
When do you like to know?
I don't know, like, what are you?
No. So, the project has been designed to be holistic.
Go for it, yeah.
The project has been designed to cover your holistic skill set with robotics. So that's
Sorry.
I'm going into
Yeah,
it.
go.
So if you don't have experience with robotics is doing electronics, and then your mechanical design and your electronic design and your software design all at once, right? You can build a great mechanical system, but if you don't wire it correctly and you don't program it, it's a husk. It's not going to do anything. In the same way, you can put a bunch of motors on a breadboard, but it's not going to do anything because it's not moving anything, right? So the Battle Boat project the goal is to help you touch a little bit of software, a little bit of electrical training, a little bit of a mechanical training with CAD and all those associated skill sets. You are you'll be given opportunities to focus in on stuff, but we believe that in order to be a engineer that can work well within a team, you need to be able to understand what the person next to you is doing. You don't need to know all the details. You don't need to understand like relative motion in order to I don't know. I can't think of an example. But yeah, go ahead.
Oh, I just wanted to like interject. Like we'll go into the battle boat stuff more on that Saturday, but the project, without like talking too much about the project itself, it's meant to kind of like get you thinking about the basics of like buoyancy of a vehicle, waterproofing, protecting electrical,
Mhm.
motor control, like writing software, like remote control abilities through like Bluetooth, like stuff like that, like propeller design, and like other things that are like really adjacent to what we do with the robot itself, except with the robot, it's a lot more serious and on a bigger scale. That's kind of, yeah. You.
I'm very interested in joining, but I don't know CAD. I don't know program. I don't know electrical. I don't know. I don't know what's going on.
That's crazy, 'cause I don't even know you.
Still have a place in this team if I.
I'm so glad you asked. You do have a place on this team. So, looking at the leadership model, oh my God, I need to gather myself. Jesus, the way the leadership system is set up is that you have your sub team lead that you can go to for questions about your sub team. I'm in Hull and I'm designing the lid for the tube. Should I go with this O-ring or this O-ring? That's a question that they should be able to answer. But maybe you're also thinking like, oh, we're storing the electronics inside the tube, so we probably need to account for the space of the electronics. Well, then you can go to the electronics division leader, or you can go to the navigation team leader who's helping build that circuit list. The idea is that there's a wide list of people with a diverse range of skills that you can go to ask questions. I also want to bring up the fact that we are also undergrads and we don't have all the answers to all the questions. We're still also partway through education, and we are getting help from some wonderful grad students. We have advisors and professors that we do chat with and will be at some of our meetings. But the thing that we hope to instill in you the most while you're on the team is learning how to find the answers to questions that you don't know the answer to. And that's a skill that will get you really, really far.
Some variety of training to be able to get into the 3D design center?
Oh, we didn't mention that.
Yeah,
That's a great question.
so
ESDC staff member Josh Cook, how can people get involved in ESDC?
Go to our website. If you just look up ESDC or UC ESDC, it'll be the first link there, and then go to new user onboarding. And then you can open up the machine training portal and sign up for trainings there. But just to enter the building, you don't need any trainings. To go to the classrooms where I'm assuming most of the meetings will be held, you don't need any trainings. But to actually use the space, the 3D printers, the collaborative space, you need training. So yeah, go there, sign up for hand tools training or anything like that, and you're good.
If you are a College of Engineering student, you automatically have access. If you're coming from outside the College of Engineering, you need to go through us. We need to sign some paperwork so that you can also get access to the space because it's primarily reserved for engineering students.
Yes. Also, if you go to the ESDC, wear PPE, safety glasses, long pants, closed-toe shoes. Yeah.
Which trainings would you recommend specifically in Republican?
Hand tools training will be the one you want to do. Everything else will
And
be
3D printing.
yes,
And
yeah,
and 3D printing. Good point. The 3D printing and hand tools. Everything else will be supplementary, and depending on the things that you want to do within the team, we will make sure you can get the training that you need.
So with that works to go into like work on software, would this training be like, would the training I would require or like be the most benefited from be like the hand tools training then?
Yes, you don't even need training. So like if all you want to do is I want to do Raspberry Pi, I just want to spend my entire life with Raspberry Pis, you don't need hand tools training. We're gonna ask that everyone at some point get hand tools training because you know we may ask you to handle the robot or just like do something, and you do need basic training to do that. So it doesn't really matter what you're doing, you should aim to get hand tools training.
Does everyone get to go to the competition?
so that's something that we can kind of talk about like as we approach, because like this will be our first year entering into the competition officially. I think generally our plan is anyone who wants to go is welcome, but there's going to be like, and we'll talk about this later, depending on the costs that it takes to go to the competition, because we'd love to take a group of like 30 people for free, but realistically, like we can't fund that on our own. So like what's most likely going to happen is we're going to ask for a certain amount from each member to cover the basic costs of that competition. But depending on how many people want to come, we're happy to accommodate everyone, organize everything. But we are going to ask for like a certain amount based on kind of travel expenses, food, lodging, all of that. Yeah.
If you have friends in finance and they want to help us raise money so we can go to competition for free, you should direct them to us. We would be very happy to work with them.
Yes. So there and then.
There are like membership fee.
There is no membership fee. There's no application. We're asking that you register, which is just like, we want your email, we want your GitHub username, we want your Discord username, we want to know like if you have any previous experience, just so we can like sort of just database that and for also what is it called?
Bookkeeping.
Diversity statistics, which the university loves. That's that's all information, but there's no, you don't need anything to be here, you don't need to pay. It's open to everyone.
Fun fact, UC Davis has some funds for like travel for like competitive teams.
Mhm.
So that's like something that can help like fund as well.
Mm.
But I also have a question on like fun events you guys have planned. So like what are some like team bonding things you guys do?
Yeah, for sure. So last year, we kind of like halfway through the year, we kind of did like team social, like movie night type thing where we all got together.
That was a great.
We watched Big Hero 6.
Watch Big Hero.
It was
Like
it
we
was
did.
it
That
was
was
pouring rain outside. It was like, yeah, it was an experience.
Video game on Jackbox.
Yeah, we also
As well.
for E-Week, the College of Engineering's E-Week, we hosted like a couple games, and just like a little game night. And then at the end of the quarter, we did our end of year social. And then also, I think the biggest social event that we do is going to the competition itself. This year, we didn't officially compete, so I think I went with one of our other members, and it's crazy. It's a ton of fun. Like, it's a week long, like it's so cool. But that will be kind of like our biggest event, and we're planning to expand because we're doing pool testing this year. So that's going to be out at the rec pool with our robot, testing its abilities and testing how the software behaves. So we're hoping to kind of make that a fun time and yeah, just have fun with it. Yeah. So if you want to be like out late at the pool with a robot, like
Any last questions?
Which pool do you guys use to test?
We will be using the rec pool?
yes,
Okay.
yes. So it will be like evening hours rec pool. Yeah.
And how do you guys plan to get it out when it sucks?
When it's stuck, I mean, my plan is to be in there with like a snorkel mask and a snorkel tube and like swimming around with it. Yeah, so if it sinks, lift it up.
It's a full workout.
Yeah,
Yeah.
you're allowed to use it as an excuse to go swimming.
Yeah.
Just don't run into the robot, like
Yeah.
Like-
for the robot's sake. Just
Yeah,
I saw that the RoboSubs for all the other teams, including yours, have similar like requirements like 4 thrusters, like robot like that. Is that basically just like standard for the competition?
none of it's like this competition is interesting because they barely specify anything. It is kind of broad as far as robotics competitions go. It's just like generally as like a control setup, the thrusters in these certain similar configurations are easy to control. And there's kind of like references out there, so people like to use them. There you go, yeah.
At some point, we did jokingly say we were gonna strap like a torpedo to.
no, we didn't say that. No, that was not something we ever said. For the record.
This is a much cooler design that we came up with first.
Not this one. This one.
Yeah, this one.
At the competition, I will say we got a lot of compliments specifically on our electrical system. Yes.
How much more is gonna get added to that robot?
Yeah, for sure. That's a really good question. So like I mentioned, redoing the electrical system. We have basically a whole grid on the bottom. So we're planning on building out a manipulator system that's mounted on the base of the robot. And then in terms of like, we're planning on redoing these like bracket mount type things. And And then in terms of like physical systems, yeah, manipulation, so torpedoes and like a manipulator, biggest kind of like mechanical additions. And then this is kind of our like big software year. So that's where, because it's an autonomous competition, like we're gonna be focusing a lot of energy on software. But there's a bunch of mechanical and
Good.
electrical projects too.
There are supplementary projects.
Oh yeah, I forgot about that.
So like, with the pool testing, the robot's gotta get to the pool. How are we taking it there? And we had the idea.
It's a pain in the ass to carry.
Wait, I mean, we're not carrying it, but we're at UC Davis. What is UC Davis known for? No. No, the one with the two wheels.
Yes, I heard it. Someone said it.
Bikes, oh my God, yes. So one of the projects we want to do is we want to have a bike mounted robot cart. So you put it on your bike, and then you bike over together as a group to the rec pool. And that's I think that
Yeah,
yeah. And then there's also like we're making a school. There's other stuff things to do.
yeah,
I like the idea of the cow more.
okay. Sure.
Take it force.
You join RoboSub, you can make it happen, Josh.
Peter. Yeah, okay.
Yeah.
Ask to the robot to do the cow.
Yeah. I don't have any good graphics here, but essentially like the competition basically is like laid out like a pool, and then there's different course items along the pool. The robot starts by passing through a gate. It gets points for like rotating in certain axes and like doing a certain amount of rotations. There's stuff like a buoy where the robot can drive up to the buoy and then back away. And if it touches and backs away successfully, points. It can fire torpedoes at the buoy, points. Targets, fire into the big target, points. Fire into the small target, points. There's also like sort of like a PVC octagon floating on the surface of the water. If the robot surfaces in that octagon, more points. If it picks up objects and like moves them around to certain locations, more points.
Dropping things.
It also, yeah, has like little onboard droppers that it can drop in specific locations, more points. I will say as an aside, this competition's really tough. So like it sounds kind of simple to just like drive into something back up. Like you'll have like teams with like 2 robots combined total like $175,000. They've been working on these robots for 25 years. They don't even bother with most of the like the picking up items task. Like they haven't bothered with it because all of their focus is on just like getting through the door, doing the simpler things, and then having really good path planning.
For reference, our robot is $5,000. So we have a pretty wide gap range that you can spend on the robot.
Yeah. But part of like the reason we want to design manipulation systems is also for remote controlled capabilities. So it's really hard to do like autonomous manipulation. And that's our goal. But then we can also do remote controlled manipulation. That will be cool. Yeah.
We're gonna wrap it up with questions. Any last ones?
Do the objectives like change yearly, or do they mostly stay the same?
They're all the same. Pretty
Generally about the same. They tweak small things.
Yeah.
Yes.
Does it have to be lithium batteries, or could we try different types of batteries? Like, I mean, let's say hydrogen cell or a thermal cell.
There are options. We can discuss that like one-on-one. And also that's like a really big meeting conversation. Yeah. Okay. All right. Well, thank you so much all for coming. I hope you guys had a good time.